In section 1.3, we focus on writing expressions, and in a nutshell, we're going to be taking words and converting those to algebraic statements. So what we want to look for will be some keywords, because certain keywords will signal a specific operation, so we want to recognize those keywords. So for example, for addition, you could see words such as sum, plus, total, more than, or increased by. You'll see examples of these in a moment. Subtraction, some keywords would be difference, less than, minus, or decreased by. Multiplication, we could see times, product multiplied by, that one's pretty obvious, or very often of means multiply. Not always, but very often. And for division, quotient, divided by, or divided into. So these are some common keywords to keep in mind. Now pay careful attention to the order, especially when you're working with subtraction or division. So for example, if you look at the phrase the difference of x and 4, that specifically means x minus 4 in that order. And likewise, the quotient of x and 4 is very specifically x divided by 4, not the other way around. So pay close attention there. And then just as expressions can contain more than one operation, you could see more than one keyword at a time. So for example, if you see the phrase 5 more than twice y, we would represent that as 2y plus 5. Notice that we take twice y first, twice y meaning 2 times y. 5 more than that would be plus 5. So we have a couple different types of models here to work with. First of all, a verbal model will use words as labels, and then math symbols that relate the words in order to describe a real-world situation. And then a mathematical model, we're going to replace those words with numbers and variables. Now, as a little bit of an added bonus, we're going to look at rates in this section. And a rate is simply a fraction, a comparison of two numbers. So a fraction that compares two quantities measured in different units. A real common one, for example, would be miles per hour. So those are going to be two different quantities using different units. And then a unit rate will be a rate with a denominator of 1. So that example of miles per hour, that's how many miles in 1 hour. That's an example of a unit rate. So speaking of examples, let's go ahead and take a look at a few here. So the directions tell us to translate the verbal phrase into an expression. So 6 more than a number y, we're going to represent as y plus 6. So we start with y, we get 6 more than that by adding 6. Now notice in this case it wouldn't matter if we said y plus 6 or 6 plus y, but it's a good practice to go ahead and do the addition, and then the 6 more would say put the 6 after the addition sign. The difference of 8 and a number x, here the order does matter. So 8 has to go first because it appeared first in our statement. So difference tells us to subtract and then a number x. So we have 8 minus x. The product of a number u and 5 you could write as u times 5, but more often you're going to see this represented as simply 5u. So typically we're going to write that number first. This is called the coefficient of u, but we'll write the number first and then the variable. 1/2 of a number k. So here's where we're going to multiply and take 1/2 times k. And remember, when using a variable, you don't even need to show your multiplication. We already know that this means 1/2 times k. And then 9 less than the cube of a number r. So we need to take the cube first. Remember that this means r to the 3rd power. Then to get 9 less than that, subtract 9. And once again, it makes a big difference which order you put these in. So 9 less than would tell us subtract 9. Hey, write an expression for the situation. So we have dollars needed for M movie tickets if each ticket costs $6. So you can think if you were going to get one ticket, that would cost $6. 2 tickets would cost $12. 3 tickets would cost 18. In other words, we're going to multiply 6 times the number of movie tickets. So 6M will tell us the cost. Number 7, number of days in Y years. Well, we know that each day has, each year has 365 days. And so if we take 365 times the number of years, Y, that will tell us the number of days in those years. The amount of money you would spend for a pair of pants that cost P dollars and a shirt that costs S dollars. So we're going to spend P dollars, and then in addition to that, so adding, we're going to spend S dollars for our shirt. So that's an S, not a 5. And then find the unit rate in feet per second. So this is actually almost a little bit of a physics problem here. All we're doing really though is converting units. And so I'm going to set this up. I'm going to rewrite this as a fraction, 6 feet over 5 minutes. And I would really prefer to see fractions written this way rather than with the slash. But now we need to convert. We need feet per second. We have feet already, but we need seconds and not minutes. And so what I'm going to do is make a conversion factor here. And I know that I need to cancel minutes. So minutes will go on the top and seconds will go on the bottom. And so I want to ask how many minutes in a second or how many seconds in a minute. Well, there are 60 seconds in 1 minute. And so now we can go ahead and multiply this out. And we're going to get 6 times 1 is 60 over 5 times 60 is 300. And for our units, the minutes here cancel out and we have feet. So 6 feet in 300 seconds. And we can divide here. We know that 6 goes into 6 once. 6 goes into 300, 50 times. And so this is equal to 1 foot over 50 seconds. And then if you were to do a division, 1 divided by 50, you would get 0.02. And then this is in feet per second. So we finally have our unit rate. So here, this is a good rate, 1 feet for 50 seconds. But to get a unit rate, we need that denominator to be 1. And that's why I went ahead and did 1 divided by 50. If you want a little reminder, you can set it up this way, 1 divided by 50. We have a decimal here, and so the decimal goes straight up. 50 does not go into 1, 50 does not go into 10, so I'm going to put a 0 there. You could also put a 0 there if you want. And then 50 goes into 100 2 times, and it goes in evenly so that we have no remainder left. And that's where I got the 0.02. Okay, number 10, we have 4 yards and 1 hour, and we're going to need a couple of conversions here because first of all we need feet, not yards. So the yards are in the numerator here. I need to put yards in the denominator here, feet in the numerator, and I know that there are 3 feet in 1 yard. So notice this is really equivalent to multiplying by 1 because these two quantities are the same. Now we need to deal with hours. So the hours are in the denominator here. I'll put those in the numerator here. And I know that 1 hour has 60 minutes. But we need per second, so we need to do another conversion just like we did here. 1 minute over 60 seconds. Okay. And we get, so now we have 4 times 3 times 1 times 1 is 12. And 1 times 1 times 60 times 60, that is 3,600. Okay. And so far for our units, let's see, yards will cancel yards, hours cancel hours, minutes cancel minutes. So in other words, we have 12 feet in 3,600 seconds. So there's our rate, but now to get a unit rate, we need to go ahead and take 12 divided by 3,600. We can simplify this a little because 12 goes into 36 3 times. That means 12 will go into 3,600 300 times. And if we take 1 divided by 300, let me see if I can make room here. So if you want to set this up, 1 divided by 300, notice that we're going to need a decimal and then 3 zeros, because 300 won't go into 10, it won't go into 100, it will go into 1,000 3 times. So we'll get 900. Whoops, and I'm going to run out of room here, sorry. And we're going to end up with the same thing over and over again. So we get 100, and then we bring down a 0 to get 1,000, and this is going to continue on, 3, 3, 3. So I'm going to round that at 003 feet per second. Okay, so there you go. Good luck with converting your verbal expressions into mathematical models. Enjoy.